Hello data science addict. In our previous video related to the linear regression, we talked about the theoretical concepts of linear regression. If you haven't watched yet, go and check out the link in description. And today we'll discuss the mathematical concept behind it. So before that, let me give you a glimpse of linear regression. Linear regression is a kind of a problem where the output variable is continuous. It tries to create the best fit line in the data so that errors between actual and predicted value should be minimal. So as you can see here, the equation of line for simple linear regression is y equal to mx plus c, and for multiple linear regression is y equal to m1x1 plus m2x2 plus c, where c is the constant, y is the output variable and x the input variable. Now here you can see the example. We have the input variable as year of experience and the output variable as salary. So this denotes that the salary is based on experience. Now let's understand this with an example. You can run the linear regression model on the above example data and you have predicted value for the actual value. Now here you can see the regression plot which shows the data points are the actual value and the line is predicted. Which one is the linear regression line? So our main goal is to minimize the errors as much as possible. Now here is a 2D plot where we have best fit line and actual data points. We are changing the coefficient value of regression line and it's shifting downwards as it's trying to minimize the error as much as possible. And best fit line is selected where the error is minimum. So your regression line is changing based on different coefficient values and you are trying to find out the best fit line for which the error between the predicted and the actual is minimal, meaning that the residual should be minimum. And your residual is the difference between actual and predicted value. Now for example, if you are utilizing the mean squared error as a cost function, now what is cost function? So here the question arises, what is the cost function? Cost function is also known as a loss function or objective function. That is a mathematical function which is used in machine learning and optimization that quantifies how well a machine learning model predictions match the actual or target values in a data set. So the goal of machine learning is often to minimize this cost function. In the case of linear regression, it shifts the best fit line with different slope and intercept values and tries to reduce the mean square error. Now here you can see the formula for mean square error, that is like where your mean square error is 1 by 2 of m and summation of I equal to 1 to m with squared of y actual and y predicted. Now in this example, we have years of experience, actual salary, predicted salary, residual and squared error. You can see the calculation of mean squared error. So first we calculate the residual, that is the difference of actual and predicted, and then the square of residual which is squared error, and then the mean square error. So the goal of machine learning is typically to minimize this loss function, which means the error or discrepancy between predicted and actual outcomes. So there are various loss functions in machine learning. That is mean squared error, mean absolute error, root mean squared error, Hubel loss, hinge loss, cross entropy loss. So for these all, we'll make a separate video where we'll discuss about each one of them. Now the main question arises, how to minimize this loss function? So there are several ways to do that, and one of them is through an optimization algorithm. Now let's discuss one of the optimization and understand how it reduces the loss in the machine learning. Today we'll understand the gradient descent and how it optimizes linear regression. Now theta naught and theta 1 is a coefficient value. Here you can see the squared loss function. As we are aware, the equation of linear regression is y equal to mx plus c. We can change the theta naught and theta 1 values and create the best fit line. Now as gradient descent is generic algorithm applicable to find the optimal solution to a wide range of problems, the general idea of gradient descent is to tweak the j theta naught and theta 1 parameter to minimize the cost function. Now suppose you are lost in the mountains in a dense fog. You can only feel the slope of the ground below your feet. A good strategy to get the bottom of the valley quickly is to go downhill. on the steepest slope. So first we define random initial points or start with 0. Then we update the coefficient based on the gradient. Now compute the gradient, that is the slope, the first order derivative of the function at the point. Now make a step, that is a move in the direction opposite to the gradient. The opposite direction of the slope increases from the current point by alpha times the gradient of that point. Alpha is called your learning rate, which is a tuning parameter in the optimization process. Now it decides the length of the steps. The algorithm iterates until we minimize the j theta naught theta 1. If alpha is high, aggressive gradient. If alpha is very slow, that is slow conversion, we need to set the alpha at optimal. In 3-dimensional gradient conversion, it looks like this. It starts with an initial random point and in each step approaching towards global minima. Now, if we come to the conclusion point, so for that, our model to perform accurately using gradient descent, values of theta naught, theta 1 and alpha plays a major role. There can be many techniques, as many as normal equation, which is comparatively easier to implement, which is used to find the correct value of theta naught and theta 1. But the most accurate result is a larger number of features that is achieved by the gradient descent. Now, hope this article provides some new insights and an idea how a simple module like linear regression is supported by pure mathematical concepts. If you like the concept, do like, share, comment and subscribe for more.